So, question 76. Oh, I'm going to have to take a packet from you.
Oh, yeah, take that one.
All right. Okay. 76. That's right. We only did 86, right? That's the only one we did. All right. So let's look at 76.
Well, I put D, and I know my reasoning, so if it's right, it's on the line.
All right. So it says the graph of the function f is shown above, which of the following limits does not exist. Well, so the limit as x approaches 1 from the left. Okay. Okay. Well, from the left, x is approaching the function's approaching 0, so it is approaching a value, right? So that's okay. B says the limit of f of x as x approaches 1 from both sides. It doesn't have a plus or minus, right? And from the left and the right, both are approaching 0, right? Even though it's a little sharp V, I think they're trying to trick people into thinking, oh, it's a sharp corner, so it's not that one. No, that's differentiability. But it is, the limit does exist. Yeah. All right, so C, 3 from the left. Okay, well, from the left, it is a straight line, and it's going over that closed circle there at 2. And even if it was an open circle, it's still approaching a height of 2, so that's okay. But limit as x approaches 3 from both sides, while on the right side of 3, we got some kind of asymptote thing. And it's even if it's not an asymptote, it's clearly not approaching 2. So D is the only one where the limit does not exist. Yep. All right, good.
There's my one.
Excellent. You might have gotten more right. You never know. Okay. And it was the first question in the section, right? Okay. All right, 77. Let f be a function that is continuous. Oh, this will be really good because they can watch the video for what they missed, right? Yeah. All right, let f be a function that is continuous on the closed interval from 1 to 3. And we're going to say that f of 1 is 10 and f of 3 is 18. Boy, I feel like they're really prepping for an average rate of change problem here. You know what I mean?
Yeah.
Which of the following statements is true? That f of 2 has to be between 10 and 18. Not necessarily. They didn't tell us that that the function only goes from that it's strictly increasing. Isn't it possible between the point 110 and 318? Isn't it possible that the graph does this? Okay, so f of 2 doesn't have to be between the two, correct? Right. Now, if they told us it was strictly increasing, then the answer would be yes. Oh wait, hang on. Oh yeah, sorry. So f at 2 could be way down here. B, f is increasing on the interval from 1 to 3. Well, it is definitely increasing for part of the way. But to say f is increasing on the interval from 1 to 3, they're actually saying it's only increasing from 1 to 3.
So it's the same thing. They're saying the same thing as the first one.
Pretty much, yeah. It's possible that there's some parts where it's decreasing. F of x equals 17 has at least one solution on the interval from 1 to 3. So from 1 to 3, okay, is there some value here where the answer is 17? Has to be, right? We can't get to 18 without passing up 17, right? So it's probably C. This is an intermediate value theorem question. It's saying that if the function is continuous, that you can't get from 10 to 18 without passing all the numbers in between. Okay? But, and you might say, well, yeah, but isn't that what A said? No, A said that at x equals 2, it's between these. Well, no, I mean, it's possible that f of 2 is down here, and then from 2 to 18, or 2 to 3, it shot up to 18, right? So it's C. Let's just look at D. F prime of x is equal to 8 has at least one solution on the interval from 1 to 3. That would be true if the average rate of change is 8. But the average rate of change here, f of 3 is 18 minus 10 over 3 minus 1 is 2. 18 minus 10 is 8, but 8 divided by 2 is 4. So we can guarantee a slope of 4 between, but we can't guarantee a slope of 8 between. Okay? Lastly, definite integral of f of x from 1 to 3 is greater than 20. Well, not if this happens. All right.
Oh, I think you put the couch here.
76 or 78. Sorry.
What kind of
Let R be the region bounded by the graphs of, oh, this is another fun one, e to the x, and we have a calculator for this one, right? Okay, e to the x, y equals e to the third. That's a constant value. It's somewhere around, it's like 22 or 27 or something, somewhere in there. So that's just a constant value. And x equals 0, which is right here. Okay? Which of the following gives the volume of the solid formed by revolving r about the line y equals -1? Well, this is a revolution of a solid, so it's going to be the definite integral. Now, apparently, the upper limit must be 3, because all the answers are 0 to 3, right? So it's got to be 0 to 3. We know it's going to be pi r squared minus pi r squared, right? We got the long and the short. The long radius, so we got -1 here. The long radius is going to go from e to the third down to -1, right? So that's going to be this minus -1. So wouldn't that be e to the third plus 1, right? So this will be e to the third plus 1, and it's going to be squared, right?
We'll just ignore them.
The short radius is going to be e to the x plus 1. E to the x minus -1.
That's our bathroom.
You okay with that? Alright, so e to the x plus 1, and that's going to be squared. Minus between, and then there's a pi. Now, in all these answers, they move the pi to the outside. So we factor out a pi, and this is what we should have. Only one of them looks like that.
I did that, but I put the one outside.
Which one?
See, like the one is for both of them.
Yeah. Yeah, start with this, see what you find, and it turns out that that's one of the answers. Yeah. With the revolutions of a solid, it's hard to simplify them because of that square right there.
Well, I gave it to them yesterday. They didn't do it. Ain't my fault. I blame society.
I think I'm going to need a calculator for the next question. Wow. We're already on the 4th. It took us 4 questions in the calculator section to get to one that actually needs a calculator. Now, do you see how that goes? That you might not need a calculator?
Much better.
Yeah. You know what you could do, by the way? You could, if you knew how to do this in the calculator, you could do it in the calculator. And then you could do all of these in the calculator, find out their actual numeric answers, and pick the right one.
Yeah.
Does that make sense? Can't all these be done in the calculator?
Yeah.
And since you have a calculator, right now, that would take time. Probably take you like 4 minutes. But if you knew that you would get the points by doing that, isn't that more worthwhile than taking a chance on other questions
Yeah.
that you might not get the points for? I always say, you've heard the saying, a bird in the hand is worth 2 in the bush, right? That means that a sure thing, even if its overall value is less than the possible gain, is still better. So go with the sure gain, okay? Now, I'm not saying do that for everything in life, but I'm saying on the AP exam, it's worthwhile. Because you know you're going to come across plenty of questions that you will not know how to answer. So may as well use the points, the time you would have spent on this question, you know? All right, see, we got the number of people who have entered a museum on a certain day is modeled by the function f of t, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened that same day is modeled by g of t. It says if f prime is equal to that function there, and g prime is equal to that function there, at what time t is the number of people in the museum at a maximum? Okay, something we haven't spent a lot of time talking about, I figured we'd get to it eventually in AP Prep, is that sometimes they don't give you one function. Okay, they give you 2 separate functions. They give you the increasing function, and then they give you the decreasing function. So f of t is how many is the number of people who have entered, right? G of t is the number of people who have left. So if we want to know how many people are actually in the museum at any particular time, what do we do with these two? We subtract them. We do the increase minus the decrease. And if we want to know when this is at a maximum, the number of people in the museum, how do we do an optimization problem? H prime of t would be equal to f prime of t minus g prime of t and set it equal to 0.
Yeah.
So what you could do is you
Take
could
the
just
functions and
plug this function into the calculator, put a minus, hit the minus button, put this function in, and then find the 0. Now, what I would do personally is I would enter this in as y1, I would enter this one in as y2, and then y3 I would enter in as y1 minus y2. That way I don't make any mistakes in terms of distributing.
and then
Find the 0.
on the graph.
Or find the zeros, and well, let's go from there.
Okay.
So let's see. F prime is 380 times 1.02 to the x power. G prime is 240 plus 240 sine, make sure you're in radians, of the fraction, pi times the quantity of x minus 4 over 12. I'll close that. Now here's what I'm going to do. I'm going to turn off y1 and y2 because I don't want them graphed. And then for y3, I'm going to hit alpha trace and select y1 minus alpha trace y2. Now, what is a reasonable amount of time for the museum to be open?
Like 6 hours.
Okay. What if they opened at 8 a.m.? Would they close by 2 p.m.?
No.
So let's go larger than 6 hours. Okay, let me tell you what I'm trying to get at. I'm wondering what if my 0 is outside the bounds of the graph? So I want to make sure I have plenty of time. So I mean, I could do like,
Let's do the whole day.
why not? So how many hours is that?
24.
24. So let's go to window and put in, what should our minimum be? We could do negative. Negative what? Well, no, because we're not going backwards in time.
I mean, why can't you do like the opposite?
Oh, I guess you could, sure. Let's do negative 24 to 24. And then graph.
I wish I was high on 5 moves.
Now, in the positive realm, how many times does it cross over the x-axis, or the t-axis? Twice. Here and here. Now you have to think, is this, so this one is somewhere around, I don't know where it is. Zero.
7.8882.
7.8882. And how about this one? Okay. Is this a minimum or a maximum?
That's a minimum.
That's a minimum. So is that a candidate?
No.
Nope. Making this the only possibility. Right?
Yeah.
And which one is that?
B.
There you go. What happened? Is it, did it say power low?
Yeah.
Let's see if I can do it. It says it right now. Say 20%? Probably 20%. Oh yeah, it'll go a little longer. Thank you. All right. Next one. 80. The derivative of the function f is continuous on the closed interval 0 to 4. Values f and f prime for selected values of x are given in the table above. If the definite integral from 0 to 4 of f prime of t dt equals 8, then what? Then f of 4 is equal to what? Okay. Fundamental theorem of calculus, what would this be equal to? Not number. Symbolically, what is this equal to? Definite integral from a to b.
Oh, okay.
See what I mean?
Yeah.
It's going to be f of
F of 4
f of 4
minus f of 0.
minus f of 0, right? And what did they say this is equal to?
8.
8. What's f of 0? It's in the table.
Oh. 5.
5. So f of 4 minus 5 is equal to 8.
Okay.
So what's f of 4? 13. That's it. E. Didn't expect it to be that easy, did you?
No.
But do you see how when you see a definite integral symbolically,
Yeah.
the first thing you should think is fundamental theorem of calculus. Even if you don't need it, the fact that your brain went to it could make it useful. Okay?
Okay.
81.
You got the video of today?
Well, I thought we were going with Cal's dance, so your stance is harder.
All right, 81. We've got a slope field.
Cal's dance is harder than mine.
It says a slope field for a differential equation is shown in the figure above. If y equals f of x is a particular solution to the differential equation through the point -1 and 2, and h of x is equal to 3x times f of x, then what's h prime of -1? Okay,
So you just find
yes, that's correct. We need h prime of
I
x.
know, it told me that. Can we go off of the basketball?
times
Yep.
Oh, yeah.
f prime of x.
Yep,
That's fine, I got it. Oh.
product rule. It's 3x, a function,
Yeah.
times f of x,
Okay.
right?
Plus.
Oh wait, hang on, we did this wrong, sorry. Not f prime, sorry. Derivative of this
Yeah.
times that, then what? Plus
3x
3x
times f prime of x.
times f prime of x. There we go. So here's, and if we want h prime of, what do we want h prime of?
-1.
-1. So everywhere we see an x, we're going to put in a -1. Do we know f of -1?
That's the graph.
No, it's in the stem of the question.
Oh.
It says if y equals f of x is the particular solution through the point -1 and 2. So
So it's 2.
it's 2. There we go. So that's a 2. What's 3 times -1?
-3.
That's a -3. So we'll put parentheses around all these things. So I got 3 times 2 plus -3. Now we just want to know what f prime of -1 is. That's in the graph.
Oh, because it's the slope. Okay.
And what is the slope?
At -1.
-2. 3 times 2
6.
plus -3 times -2.
6.
There you go. E, 12. The mystery is unraveling, right? 82. If f is a continuous function such that f of 2 is equal to 6. So we have a point here, 2, 6, right?
Mhm.
Which of the following statements must be true? is the limit as x approaches 1 of f of 2x 3. What is always the first step in any limit? Plug in. So if we put 1 in for x, we get f of 2 equals 3. But this says f of 2 equals 6. So A can't be true. Right?
Yeah.
Okay, if we put a 1 in here, we get f of 2. And f of 2 is not 3. Alright? Okay. Now understand, actually it's not. It could be true. It could be true. Isn't it possible that the graph does this? As x approaches 1, that there's a hole here, and that the output is 6 up here, but this is 3? Isn't that possible?
And then it's not continuing.
I didn't see that statement. You're right. But here's the key. Even if that could have been, this says which of the following statements must be true. Must be. Actually, no, you're right. That continuous statement is necessary. You're right. Good job. I didn't notice that. All right, B. What are we going to do here?
Plug it in 2.
And what do we get?
F of 4.
Equals 12. Must that be true?
No.
Might it be true?
Yeah.
But we don't know for sure, right? All right. C. X approaches 2.
You gotta go on the thing with the graph.
So F of
It's
2,
gonna be 0 over 0.
0 over 0. Is it possible that 0 over 0 equals 6?
Yeah.
Okay? Actually, no, it's not because of what you said before, because it's continuous.
Wait, so
Oh, actually, no. You know
the
what?
whole could be.
No, you know what C is asking about? C is asking about F prime, not F. Doesn't that look like the limit definition of the derivative?
Yeah.
Yeah. So that's not asking about F of 2. That's asking about F prime of 2. All right, D.
Okay. F of 4 equals 36.
Maybe? Must be?
Nope.
Okay. E.
So F of 2 squared. Yeah. So that's it. Cause F
Yep.
of 2
Is 6.
6.
And 6 squared
is
is 36. There you go. Good. A little logical unpacking, puzzle, logic, little logic puzzle thing there. All right, 83. A particle moves along a straight line with velocity given by that thing. You know what I'm tempted to do here? Put it in my calculator. So I'm like, all right, hang on a second here. This is I'm seeing a crazy looking velocity function there. So maybe I want to see it in my calculator. 5 plus e to the power of x over 3, right? And what did I tell you to do after you have entered a function in your calculator?
Do the window.
Window. Let's hit window. Do they give us any kind of interval?
It has to be greater than 0.
Okay, so let's put x min 0, and then let's put something reasonable for x max.
Such as.
Oh, sorry.
I don't know. They ask about 4. They ask about time 4. You want to just put in 5?
Yeah, sure.
And then what do we hit next?
Graph.
Zoom
Zoom.
0.
You have to go through these.
All right. All right, there's a graph. It says, what is the acceleration of the particle at time 4? Oh, it's easier than I thought it was going to be.
Find the derivative.
There you go.
And then graph it.
You don't have to graph it.
Oh,
They want to know the numerical. Just plug in 4. But are we plugging 4 into velocity? No. What are we plugging 4 into?
the acceleration.
The acceleration. How do we do that on here?
We got money.
Oh,
You know how to do it.
you said something.
I have when I was like 10.
A 6.
Second trace, go to the calculate menu.
Uh-huh.
Option 6 gives you the derivative,
Uh-huh.
right? And then if we put 4 in, what does it give us?
1.264.
Is that one of the answers? One of the options?
Yeah.
Okay, there you go.
Okay.
This is what I call an easy question.
I'm gonna write it out.
Yeah. All you had to do is key the velocity in, and then use the numerical derivative feature on the calculator. That's one of the 5 things you have to know how to do on the calculator, is find a numerical derivative. Okay. All right, 84. A home uses fuel oil at the rate of R of t, and that's a crazy function, gallons per day, where t is the number of days from the beginning of the heating season. To the nearest gallon, what is the total amount of fuel used from time 0 to time 60?
Okay, so you're gonna integrate
Okay? From?
0 to 60.
How do I do that in the calculator?
Math 9.
Math 9, 0 to
6.
60 of
10
10
plus
plus
8
8
sine
sine
x over 60.
x over 60 dx.
I got 824.
Okay?
Everything, so then it's d.
There you go. Another easy question, right?
Yeah.
All right. 85? The function f is defined on the open interval from 0.4 to 2.4 and has first derivative given by f prime sine of x squared. All right, what are you thinking here? Would you like to see what this looks like?
Sure.
Me too.
Why are you killing me?
Because I have a calculator, right? Because I have a calculator, I'm constantly thinking, is there some way I can see this function, right? So I'm putting in sine of x squared. And then what do I do after I put a function in?
Window.
Window. And what's my window going to be?
0.4 to 2.4.
0.4 to 2.4. And then what do I press?
Zoom 0.
Zoom 0 so that it'll fit it and I can see a nice picture of this derivative on that interval that they're talking about. Okay?
I hit something weird. Hold up.
Okay. And then it says, which of the following statements is true? F has a relative maximum on the interval. What do you think of that?
What happens then?
What are you looking at in that screen?
You look at the derivative.
The derivative.
So wherever it crosses
Uh-huh.
from top to bottom is the relative.
There you go. Does that happen here?
Yes.
Okay, so we have a relative maximum, right?
Mhm.
All right, what's option 2 says F has a relative minimum. I don't see one either, but you know what some people are going to be thinking when they look at this graph?
Oh, there's bound to be one.
Yeah, well, not only that, they're thinking this is F, and they're going to say, oh, there's a maximum, there's a minimum.
Oh.
No, this is F prime.
Yeah.
No minimum here, right?
Mm-hmm.
All right, but you're right, they're going to be thinking. Okay, so then 3, the graph of F has 2 points of inflection.
So,
What defines a point of inflection?
Alright, so the second derivative
Correct.
is changing from concave up to concave.
There you go, a change in sign on the second derivative. How does the second derivative relate to what we're looking at here?
The first derivative,
This is the first derivative.
it's going to be changing from increasing, decreasing, or opposite.
Does that happen here?
Yeah,
How many times?
twice.
So that means 2 inflection points. Inflection point here, and not on this, but on F. Inflection point here, because the second derivative is going from positive to negative, and then negative to positive.
Okay, so the relative maximums and minimums
Of the derivative indicate the zeros or inflection points of the original function. That's correct. Yep. So which option are we going to pick here? D, 1 and 3 only. Very good. All right.
Alright, these are better than the...
Yeah, see? Not so bad, right? All right, we already did 86 in the previous video, right? You wanted to do it again?
Yeah.
Right now, or let's do this. Let's do some more, and then because you can always look at the video and see and try and follow it again, or if we have time at the end, or if my battery runs out.
Yeah, we're low on time.
Yeah. Okay. 87. The first derivative of the function g is given by g prime, which is cosine of pi x squared. Okay. Guess what I'm thinking I want to do? Yeah, I want to graph it because it's giving me and it gives me an interval, right? So that's helpful.
Yeah.
So I'm going to put in cosine of pi and then x squared. And then I'm going to go window. And what am I going to put in for window?
Negative 0.5,
Up to,
1.5.
and then what am I going to hit?
Oh, that's cool.
Zoom 0. I want to get a nice picture of this. It says, on which of the following intervals is g decreasing?
Well,
Are we looking at the original or the derivative?
looking at the derivative,
Okay.
so wherever it's below the x-axis.
Okay, does that happen?
Yep.
All right.
From that point to that point.
Okay, and what's that about equal to? Because look, all these answers are sort of all over the place, right? So we could do a quick trace. You could do the zeros if you want.
So the first one's less than 1.
Yeah, the first one's less than 1. The first one's about 0.7.
Why won't it let me do
See
it?
this? See how I'm kind of going near it? It's about 0.7. Where's the second one at?
I heard how you hit
A little bit.
Hello?
A little bit more than 1? Yeah, it looks like about 1.2 or so, right? So is there one that's near 1 point, or 0.7 up to 1.2?
Yeah, that's C.
See, there you go. That's the answer. Getting easier, right?
Yeah.
Oh, only a few more here.
One of them slowing down for the fire.
The height above the ground of a passenger on a Ferris wheel in T minutes after the ride begins is modeled by the differentiable function h, where h of t is measured in meters. Which of the following is an interpretation of the statement that h prime of 7.5 equals 15.708? What does 7.5 represent in this question? A what? A time, right?
Right there.
Okay.
So after
Right away.
7.5 minutes,
Okay, there you go.
there's going to be the
And what does h prime equaling 15 mean? What is 15 representing?
meters per second.
Right, it's a rate of change, right?
Yeah.
Because h prime is the rate of change in, right? Okay.
So it's going to be 15.708 meters per minute.
Yep. When the passenger's 7.5 meters above the ground? No, that doesn't make any sense.
After 7.5 minutes.
Yeah, that sounds about right. 7.5. Which one is that?
B.
A B. Ferris wheel is no. Ferris wheel is turning at a rate. Is h the rate of change in the Ferris wheel?
The passenger's height above the ground is increasing. Yeah. It's
Yep.
D.
It's D. Yep. And increasing because it's a positive 15.708. Right? All right, good. All right, 89. A particle moves along a straight line for 6 seconds so that its velocity is modeled by the graph shown. During the time interval 0 to 6, what is the total distance traveled? What do we know about total distance traveled?
It's absolute value.
Absolute value, which means all the negatives are going to be, there you go. So how do we find, what would we do to velocity to get total distance traveled?
Just find it and find the.
It's a total, right?
the
Integrate.
absolute value of velocity.
There you go. And what is, if we have a graph, what does integration mean? How do we use a graph to find a definite integral?
You find the area.
Area. There we go. All right. So so let's do some area here.
Oh, good.
What's the area of the? What do you see there?
So I see a square and a triangle.
A square and a triangle. Okay. How much is the square?
4.
4. And how much is the triangle?
1.
1. Okay. So that's 5. Okay. Good. And then what else do we have?
Another triangle and a square.
Okay.
Bottom.
Yep. And what are those?
This one's 1.
Okay. Oh wait. Hang on. I don't think it's 1.
So. Oh, it's 1 half.
It's half. Okay. And then the other one?
And then the other one is 1.
1. All right. So what do you think?
1.5 plus 1 is 2.5 plus 4 is 6.5.
All right. D.
Oh, wow.
Very good. 90. 90 is good. We're going to have just enough time here, I think. Unless my battery runs out. Let f be the twice differentiable function on the interval a to b. F prime is greater than 0. What does that mean?
That means it's increasing.
Increasing, okay? So can we knock any of these out automatically? Because it says which of the following is the graph of f.
E and D.
Yeah, E and D are not possible because they're decreasing. And F double prime is less than 0 on the interval.
Okay, down.
Okay, so which one is it?
C.
There you go.
Those are my favorites.
Yeah, those are good ones, aren't they? Yeah. All right. Okay. The graphs of f and g are shown above. If h of x is f times g, then h prime of 6 is what?
Do the product.
All right. So h prime of x is going to be equal to
Okay, so f prime of x
f prime of x.
times g of x.
Okay.
plus
Uh-huh.
f of x
F of x
times g prime of
times
x.
g prime of x. Okay? So h prime of 6 is equal to f prime of 6 times g of 6 plus f of 6 times g prime of 6. What's f prime of 6? So we gotta go all the way over to 6. 3, 4, 5, 6.
Which one's f? Oh, this one. It's 2.
What does f prime mean?
Oh, the slope.
Yes.
Okay, so it's gonna be
Negative 2? Alright, and what's g of 6?
um 4.
4. Plus, what's f of 6? 2. And what's g prime of 6?
Negative 1 half.
Negative 1 half. So we got negative 8, and then 2 times negative 1 half is negative 1. So plus negative 1. What do we get?
Oh, negative.
Negative 9, which is option A. I don't think we have, let me go, I'm probably going to turn this off because I know that if the battery hasn't died already, it's about to die. Oh, it's still going.